We're asked to find the volume formed by the region enclosed by x equals 9.5y, x equals y cubed, with y greater than or equal to 0, rotated about the y-axis. I've already shown the bounded region here on the coordinate plane, and we are rotating about the y-axis. If this region is rotated about the y-axis, we get this solid shown below. We will determine the volume using the washer method with rotation about the y-axis, where the volume is equal to pi times the integral from c to d of the square of big R of y minus the square of little r of y integrated with respect to y. To help us set this up, let's draw a rectangle that would represent one washer of the volume rotated about the y-axis. So the rectangle will be perpendicular to the axis of rotation, let's say approximately here. Notice the thickness of the rectangle is delta y, which is why we integrate with respect to y. And big R of y is the outer radius, which would be this length here. Little r of y is the inner radius, which would be this length here. We'll notice how big R of y is given by the equation x equals 9.5y. Little r of y is given by x equals y cubed. And then for the limits of integration with respect to y, we integrate from y equals 0 to the y-coordinate of this point of intersection. So we'll have to find the y-coordinate of this point of intersection algebraically. But let's go ahead and begin to set this up. We have the volume is equal to pi times the integral. We'll come back to the limits of integration where the square of big R of y is the square of 9.5y minus the square of little r of y is the square of y cubed. And now to determine the limits of integration, we start integrating at y equals 0. And again, the upper limit of integration is the y-coordinate of this point of intersection here. To find the y-coordinate, we need to solve the system of equations x equals 9.5y and x equals y cubed for y. So let's work on that below. Let's perform a substitution. Let's substitute 9.5y for x in the second equation, which gives us 9.5y equals y cubed. Let's set the equation equal to 0 by subtracting 9.5y on both sides, which gives us 0 equals y cubed minus 9.5y. Let's factor out the common factor of y. (9.5) is not a perfect square, but it is equal to the square of the square root of 9.5, so we can factor this as y times y minus the square root of 9.5 times y plus the square root of 9.5. So our solutions are y equals 0 as well as y equals plus or minus the square root of 9.5. And we can see from the point of intersection it's in the first quadrant where y is positive, and therefore the upper limit of integration is square root 9.5. And now let's work on evaluating the integral. We have the volume is equal to pi times integral from 0 to the square root of 9.5. The square of 9.5y is equal to 90.25y squared. And then we have minus the square of y cubed is y to the 6th. And now let's find the antiderivative. The antiderivative of 90.25y squared is equal to 90.25 times y cubed divided by 3, or 90.25 divided by 3y cubed, minus the antiderivative of y to the 6th is y to the 7th divided by 7, or 1/7 y to the 7th. Let's continue on the next slide. So we have pi times big F of the square root of 9.5 minus big F of 0. So substituting square root 9.5, we have 90.25 divided by 3 times the square root of 9.5 cubed. And then we have minus 1/7 times the 7th power of the square root of 9.5. And then for big F of 0, when y is 0, both quantities are 0. So let's now go to the calculator. to 4 decimal places, we have 1,581.3325. Which does give us the volume of the solid if the region shown here is rotated about the y-axis. I hope you found this helpful.